Hello everyone, in this video we are going to solve the problem number 1.25 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A point moves in the plane xy according to the law x is equal to at and y is equal to at times 1 minus alpha t, where a and alpha are positive constants and t is the time. So let us say that this is the x-axis and this is y-axis in the xy plane. Let us represent any point in this plane as x comma y coordinate, and the motion of the point is given according to the equation x is equal to at and y is equal to at times 1 minus alpha t, where a and alpha are positive constants. Now in the first problem it is asking to find the equation of the point's trajectory, that is y as a function of x, and also to plot that function. Okay, so let us say in the first equation x is given as at and y is given as at times 1 minus alpha t. So here if we see, the x is a function of time, y is also the function of time. In order to find y as a function of x, we have to eliminate t from both the equations. So from first equation we can write t is equal to x upon a, and if we substitute in the second expression, then we can write it as y is equal to a times x by a into 1 minus alpha times x by a. So finally we will get y is equal to x into 1 minus alpha by a into x. Okay, so this is the expression we got, which is the y as a function of x, and it is representing the trajectory of the point in xy plane. Okay, and now if we plot this particular equation, this is nothing but the quadratic equation, and if we write the standard form of the quadratic equation, then we can write it as y is equal to c times x minus a into x minus b, where if let us say c is positive, then this is representing the upward parabola, and if c is negative, then this is the downward parabola, and the roots of this equation we can write it as x is equal to a and x is equal to b. Okay, so similarly if we write this particular quadratic equation in the standard form, so for that we have to take a common, that is minus alpha by a. So if we consider the common, that is minus alpha by a into x, then we can write x minus a by alpha. Now if we carefully look at this particular expression, then in this expression alpha by a is the positive constant, so minus a alpha by a will be negative, and if it is negative, that means it is representing the downward parabola, and the roots of this equation are x is equal to 0 and x is equal to a upon alpha. Okay, so let us plot this particular function. For example, this is x-axis and this is y-axis. The roots are x is equal to 0 and x is equal to a upon alpha. So the plot of this particular function will something look like this, which is the downward parabola. Now coming to the second part of the problem, it is asking to find the velocity and the acceleration w of the point as the function of time. So let us first write the position vector. So the position vector, let us represent it as r vector, that we can write it as xi cap plus yj cap, and x is given as ati cap plus y is given as at times 1 minus alpha t j cap. Let us expand this particular function. We will get ati cap plus at minus a alpha t square j cap. So this is the position vector we are having Now in order to find the velocity vector, we can differentiate this position vector, that is dr upon dt is equal to d by dt of at I cap plus at minus a alpha t square j cap. Okay. Now if we differentiate at, then we will get a, because a is constant and the differentiation of t is 1. So we will get a I cap, and here also the differentiation of at will be a, minus here the differentiation of t square is 2t and a alpha is constant, so we will get 2a alpha t into j cap. So this is the expression of the velocity vector we got. Now if we find the modulus of this velocity vector, then we can write a square plus a minus 2a alpha t whole square. Okay. If we expand this particular expression, we will get a square plus 4a square alpha square t square minus 4a square alpha t under root. Okay. So we will get 2a square plus 4a square alpha square t square minus 4a square alpha into t. So this is the magnitude of the velocity vector. Now let us come to the acceleration vector. If we write the acceleration vector, which is represented by w vector, so this is equal to derivative of the velocity vector with respect to time. So we can write d by dt of what is velocity vector, that is a I cap plus a minus 2 a alpha t into j cap. Okay. So the differentiation of a is 0 plus 0 minus differentiation of 2a alpha t is 2a alpha, because 2a alpha is constant and the differentiation of t is 1. So we will get 2a alpha times j cap. So the acceleration vector, we can write it as minus 2a alpha j cap. If we write the modulus of this acceleration vector, then we can write it as minus 2a alpha j cap mod, that is equal to 2a alpha. Okay. So here we got the velocity vector, acceleration vector, and the magnitude of velocity and the acceleration vector. Now in the last part of the problem, it is asking to find the time moment t naught at which the velocity vector forms an angle pi by 4 with the acceleration vector. Okay. So let us say in the C part, velocity vector is given as a I cap plus a minus 2a alpha t j cap. Okay. So we can also write it as a I cap minus 2a alpha t minus a into j cap. This is the velocity vector, and acceleration vector is equal to minus 2a alpha j cap. Let us first represent the velocity vector as the component in the x and y direction. So this is a, the component of velocity in the x direction, and this is 2a alpha t minus a, the component of velocity in the minus y direction, and this is the acceleration vector, and this is the acceleration vector w. The magnitude of this acceleration vector is 2a alpha, and it is in the negative y direction. Now this is representing the resultant velocity vector, and it is known that the angle between the velocity vector and the acceleration vector is pi by 4. Then we have to find the time instant at which this particular thing will occur. Okay. And this angle is also the angle between the resultant velocity and the y component velocity. So if we draw the vector diagram of the velocity, then this is representing 2a alpha t minus a, this is a, and this is the resultant velocity vector, and this particular angle is pi by 4. So we can write from this particular triangle that 10 pi by 4 is equal to a divided by 2a alpha t minus a. 10 pi by 4 is 1, that is equal to a divided by 2a alpha t minus a. So from here we will get 2a alpha t minus a is equal to a. So we will get t is equal to 1 upon alpha. So this is the time at which the angle between the velocity vector and the acceleration vector will be pi by 4. Okay, I hope the entire procedure is clear. Thank you.